Hello everyone, welcome back to my channel. Hi Mathematics. Today we have very interesting and in the same way this is a very tricky question. We need to find our x and y. We know that x plus y equal to 1, so our addition equal to 1 and our multiplication x times y equal to 1. Right now you can easily pause the video and try to guess what is this x and y. You can easily think a little bit, how is it possible? Addition equal to 1, multiplication equal to 1. You can also write your assumption, write your solution down into the comment section. Okay, so right now let's start. First of all, let's rewrite our first equation, so x plus y equal to 1. Let's see what will happen. As a result, we have x plus y is equal to 1. According to school knowledge, we need to express from here our y, and then we will plug in this y instead of this y in the second equation. As a result, from here, we have that our y equal to 1 minus x. And right now, let's plug in this expression into our second equation, because we know that y equal to 1 minus x. We're gonna plug in this instead of this y in the second equation. Let's do this right now. So as a result, we have x times 1 minus x times 1 minus x equal to 1 times 1 minus x equal to 1. Right now, let's simplify this a little bit. We have only one variable. We don't know about this. We don't know the answer real quick, because this looks like a quadratic equation. Yeah, as a result, we have x minus x squared, okay, x squared equal to 1. And yeah, this is a quadratic equation, so right now let's solve this basic quadratic equation, but let's change in order a little bit, because we prefer our second power on the first position, x on the second position, and our constant on the third position. So right now let's change an order real quick. So as a result, what do we have? Minus x squared plus x, and minus 1 from the left side equal to 0. And the last tricky move, we're gonna multiply both sides by minus 1. Okay, because we have minus, we don't need it, so let's multiply or divide, doesn't matter. It depends on what country you live in. Yeah, we need to multiply or divide, doesn't matter. Yeah, so as a result, we have x squared minus x and plus 1 equal to 0. Alright, this is our quadratic equation. So right now let's solve it. Real basic equation. We have like our coefficients, so our a is equal to 1, b equal to minus 1, and c equal to 1. Let's plug in each of these coefficients into this spot, into our discriminant spot. We have the b squared minus 4ac. As a result, we have b squared, we have minus 1 squared minus 4 times a times 1 times c times 1 equal to, as a result, we have 1 minus 4 times 1 times 1 equal to 4. As a result, we have minus 3. So it tells us, because a lot of students are confused at this moment, because they say, okay, we have right here a negative sign, so it means that we can solve it, we don't have a solution, we don't have a root. But to be honest, it tells us that right here we have complex pairs of solutions. So right now let's solve it. Let's see what will happen when we find our first x first and second. So x first and second equal to all known formula, minus b plus minus square root of d all over 2a. Let's plug in each of these elements into this spot. So we have minus 1 plus minus square root of discriminant square root of minus 3 and all over 2 times 1. Right now we're gonna have the next thing. We can write it as 1, because negative, we have positive. We have plus minus square root of minus 3. We can easily split it. We can easily write it as square root of 3 times square root of minus 1, because right now we know that we have complex unit, and this is our our complex unit. This is our I. So as a result, our x first and second equal to, we have 1 plus minus I square root of 3 all over 2. Or for better understanding, maybe a lot of students want to see this real part and imaginary part, we can easily divide it by 2. So numerator we divide by 2 by parts. So this one we divide by 2, so we have 1/2, this is our real part, plus minus I square root of 3 over 2, this is our imaginary part. Okay, this is our x first and second. We're gonna check it a little bit later, but right now let's find our y first and y second. Don't forget about our substitution, because right here we have y equal to 1 minus x. So y equal to 1 minus x. So we're gonna have y first and y second. So let's do this right now. So from here we have y first equal to 1 minus x first. X first, let's take, for example, with the positive sign. Okay, doesn't matter. With the positive, negative, we're gonna find it y first, y second, doesn't matter, because we're talking about pairs. So equal to 1 minus with the positive sign. Let's take with the positive. So 1/2 minus 1/2 plus I square root of 3 over 2 equal to, so we have 1 minus 1/2 minus I square root of 3 over 2. When we subtract it, we have 1/2. So as a result, we have 1/2 minus I square root of 3 over 2. So as you can see, completely the same thing as x first with the positive sign, y first with the negative sign. So as you can see, we just changed the sign, but it's not like change. We solve it and we see completely the same expression, but with the different signs. Okay, so y second equal to 1 minus x second with the negative sign. Let's take with the negative sign. So as a result, we have 1 minus, and with the negative sign, 1/2 minus I square root of 3 over 2. As a result, we have 1 minus 1/2 and plus I square root of 3 over 2. As a result, right here we have the same 1/2. So we have 1/2 plus I square root of 3 over 2. And right now I'm going to write both pairs, the first one and the second one. It looks like this is our answer, but in the few seconds we will check it. Let's see what will happen when we check it. So let's split this part, yeah, and we're going to write our pairs. So our pair x and y equal to, let's start with the x first, y first. X first with the positive sign, so we have 1/2 plus I square root of 3 over 2, and we have y first with this one, so with the negative sign, so we have 1/2 minus I square root of 3 over 2. This is our first pair of solution, pairs of root, and we have absolutely the same thing with the second one, but right here negative, right here positive. So we have 1/2 minus I square root of 3 over 2, and the second one 1/2 plus I square root of 3 over 2. These are both pairs of roots, the first one and the second one. And in the end, I'm going to check it because as you can see, we have a complicated expression. In the beginning, we had x plus y equal to 1, so it's not that hard. Yeah, we have only 1, not a huge coefficients. We have x, y equal to 1 as well. So right now, let's check our roots, okay? Let's take, for example, the first one, or doesn't matter, the second one, because right here we are talking about addition, yeah? We're talking about addition, so it doesn't matter. This one we add to this one, or this one to this one, doesn't matter, because we're talking about addition. 2 plus 3 equal to 3 plus 2, absolutely the same thing. And the same thing with the multiplication, so it doesn't matter. 2 times 3, 3 times 2, so we can get one of these. We don't need to get to check both of these. We can easily take this one or this one, doesn't matter. Let's test, for example, these pairs. So the first one, we are talking about addition, x plus y. So we are talking about this, we add to this one. So we have 1/2 plus I square root of 3 over 2, and plus the second one. So plus 1/2 minus I square root of 3 over 2. Right now, this one we can easily cancel with this one. And as a result, 1/2 plus 1/2 equal to 1. So as a result, our addition works perfectly. So our x plus y equal to 1 works absolutely great. Right now, let's check our product. Let's see what will happen when we check our product. We're going to check right here. So we're going to take 1/2 plus I square root of 3 over 2. We're going to multiply it by 1/2 minus I square root of 3 over 2. And let's see what will happen right here. Right here we need to have 1 on the right side, but what do we have on the left side? This is our formula. This is our basic school formula. Just look at it. So we have a square minus b square. This is our a minus b times a plus b. And if you look closely, we have this is our a, this is our b, this is our a, this is our b. Right here we have a plus b. Right here we have a minus b. So as you can see, we can easily write it as a square minus b square. So a square, we have 1/2 square. We're going to raise this minus b square equal to I square root of 3 over 2. We're going to raise this to the second power, and this one need to be equal to 1. Let's check it. Let's see what will happen. First of all, right here 1/4 minus, we need to raise to the second power each of these elements, okay? Numerator, denominator. So as a result, we have I square times square root of 3 square, and we're going to divide it by 4. All right, as a result, we have 1/4 minus I square equal to minus 1, yeah, minus 1, times square root of 3 square equal to 3, and over 4. As a result, we can easily write this fraction as 1/4 minus this fraction, we can easily write as minus 3/4 with the parentheses, of course. And the last tricky move, minus minus gives us plus, so as a result we have 1/4 plus 3/4 equal to 1. Yeah, we have 1 plus 3 equal to 4, 4/4 equal to 1. So our product works absolutely perfectly right here. So as you can see, our roots is absolutely correct, which is also really great that we solved this question. One really important moment, that these are our complex solutions, complex roots. This is not a real number roots, because this is not possible that our addition equal to 1 and our multiplication equal to 1 at once. Yeah, so we need to look at it in a perspective of complex plane. So as you can see, we solved this question. So this is my explanation to that question. I really hope you understand it. I really hope you learned something new. You can also write your question down into the comment section, write your notes down into the comment section. It will be really interesting to read about it. Also write your questions, write your thoughts about this question. What do you think about this approach? Maybe you have a faster approach. It is also really interesting and also really great to read about your approach down in the comment section. So thank you everyone for your time. Wish you all the best in your math adventures. See you in the next videos.